So now we want to not only solve exponents, but we want to deal with them in logs. And here's your two keys right here. Y equals b to the x is the same as x equals log base b of y. Now I actually usually write this slightly different. I usually write it the other way. I'll say b to the x equals y. And log base b of y equals x. The reason I do that is to go from translating exponential form to logarithmic form. I'll use this trick where I start at one side. I start on the left, I go to the right, and then I come back around to the middle. So it's the same thing over here. I'd start with the leftmost variable, which would be b in this case, then to the x, then to the y. You're probably wondering, like, how does that work? That means b to the y equals x, or pardon me, log base b of y equals x is how it would look down here. But if I want to translate log base b of y equals x into exponents, I'd say b to the x equals y. So let's do some different letters there and show you guys how that would be similar. Log base w of z equals q. If I wanted to change this log form into exponential form, I would say w to the q equals z. If I wanted to go the other way, let's say I had, I don't know, let's pick three different letters. M to the r equals t. Then I'd start with the leftmost, log base m of t equals r. There we go. And this helps us rewrite things in either exponential or logarithmic form just to kind of help us simplify statements like these up here. So what I want to look at then is 2 to some power equals 8. I don't know what that power is, but if I rewrite it as an exponent type equation, it'll say 2 to some power equals 8. Oh, well, that number there then must equal 3. That means that this whole left side would simplify to 3. So it just equals 3. Log base 2 of 8 equals 3. Similarly to this piece right here, now remember 1 over 25 is really 5 to the negative 2. So I have log base 5 of 5 to the negative 2. So now you have to think about 5 to what power equals 5 to the negative 2. So, well, it's already kind of written in there. It's saying 5 to some power equals 5 to the negative 2. Well, that question mark is negative 2. Then that means log base 5 of 1 over 25 equals negative 2. Alright, we keep on going here. And now we're getting a little bit harder. This says 8 to some power equals square root of 2. So let's call this x. And we're going to say 8 to the x equals square root of 2. Now 2 is really 2 to the 1/2. Now we're going to start incorporating some of the things that we were looking at earlier. This is 2 to the 1/2. I can rewrite this equation but have the bases the same so that I can match the exponents. This is really 2 to the 3rd power times to the x power equals 2 to the 1/2. Then that tells me that 3x, I'm going to multiply those pieces, equals 1/2. Well, when I divide each of these sides, it's going to be x equals 1/6. There's that one. This one here was negative 2. And the first one was 3. You guys think you can do the last two? Let's make it a little bit easier. This one, there's two ways you can do it. You can kind of treat the log piece by itself and then multiply by 5 in the end. Or you can pull the 5 in with some other rules that we haven't really looked at yet, but we will. So let's start by looking at this as 6, just this inside piece. 6 to some power equals 1. 6 to some power equals 1. Well, that question mark then is 0, because anything to the 0 power equals 1. That's the only way you can get back to 1. So that means log base 6 of 1 equals 0. So 5 times that would give us our final simplification. So 5 times 0 equals 0 still. So the answer would have been 0. This one's kind of hard because it says 7 to some power equals 0. 7 to some power equals 0. Think about that for a second. That means you have to multiply or divide 7 somehow and get back to 0. You can't really do that. You can't multiply or divide 7s and get back to 0. So back in the day when there was no way to answer something because it doesn't work, you say no solution. We don't do a lot of that in calculus. But this covers Algebra 4 calculus where we dealt with a lot of the no solutions. It's one of those times we have to say that. If the base is not specified in a log, we're going to say that it's 10. So we could even just write in here, log base 10, log base 10, log base 10, log base 10, and log base 10. So let's look at the first one. 10 to what power equals 100? That's easy. This equals 2. 10 squared equals 100. So the whole thing would equal 2. 10 to what power equals 1? It's that same thing. Anything to this power equals 1? 0. Now we can do this again 2 different ways, but let's keep it simple and just do the stuff in parentheses first. 10 to some power equals square root of 10. Well, remember that square root of 10 is 10 to the 1/2. So what would log base 10 of 10 to the 1/2, what would that equal? Well, 10 to what power equals 10 to the 1/2? It's 1/2. So this inside parentheses is just 1/2. So it would be 5 times 1/2, which is just 5 halves. Again, similarly here, we have something in a base of 10, but it's not what we're necessarily used to. 1 over 1,000 is the same as 10 to the -3. So this is saying 10 to what power equals 10 to the -3? It would be -3. That's what that piece would simplify to. This one's almost complicated, but it's actually very simple. We're being asked 10 to what power equals 10 to the square root of 5. So 10 to what power equals 10 to the square root of 5? What's the question mark? It's square root of 5. It's that easy. That easy.